Okay, so I just wanted to run through about writing configurations of ions, all right? So if you were asked to write the electron configuration for the aluminium ion like this, then you'd say to yourself, right, aluminium atom, okay, Al atom has 13 electrons. I know that because on the periodic table, the smaller number, the atomic number is 13. Now start and say to yourself, right, what has happened to the atom to form this aluminium plus 3 ion? Well, if it's a plus 3 ion, the atom is after losing 3 electrons. So now the ion must have 10 electrons. It had 13, the atom had 13. To make the ion, it lost 3, and now the ion has 10 electrons. And then you just write something with an electron configuration of 10, okay? So that would be the configuration for the aluminium ion, all right? Now, if I just show you there, just clear that for a second and show you what about if it was a negatively charged ion. So sulfur atom, so you look up the sulfur atom on the periodic table, it has 16 electrons. Now, what has happened to the atom to form the sulfur ion? Well, if it's a negative ion, negative by 2, what that means is that the atom has gained 2 electrons. So now the ion has 18 electrons, and write then the configuration for something with 18 electrons, okay? 3s2 and 3p6. Is that 18 added up? 2 and 2 is 4 and 6 is 10. It is. Okay, so that would be the configuration then for s minus 2. So I'll just clear that now. Now, what about if they asked you to identify something like this, okay? Plus 2. So you need to say to yourself, well, this is an ion because it's charged. It's a charged atom. It's a positively charged ion. Again, start with the atom. So say to yourself, right, I don't know much about the atom, but I do know that the ion has how many electrons? 1, 2. So that's 2 and 2 is 4 and 6 is 10. So the ion has 10 electrons. Now, how did you form this ion? Well, what happened to the atom? If it's a positively charged atom, it means it lost 2 electrons. So originally the atom must have had 12. And now you need to see in the periodic table and go and see what has an atomic number of 12, and you'll see that it's magnesium. Now, you're asked to identify that. It's still an ion. So your answer would be the magnesium ion, Mg plus 2 ion. You've identified it, okay? Now, clear that. Now, what about, again, if they asked you to identify something like this, okay? So again, you know that it's an ion because it's charged. Now, count up and see how many electrons the ion has. So 2 and 2 is 4 and 6 is 10. So the ion has 10 electrons. And then say to yourself, right, what happened to this atom to make this ion? So it's negatively charged this time. How do ions become, what happens to the atom to form a negatively charged ion? It gains 2 electrons, okay? So if the atom gains 2 electrons and then has 10 electrons, then the original atom must have had 8 electrons. And you go to your periodic table and you say to yourself, what has 8 electrons? Well, oxygen has 8 electrons. You're identifying an ion, an O minus 2 ion, okay? Now, just finally, the exceptions to Aufbau's principle. Do you remember those? These are atoms now, okay? But if you look up chromium on the periodic table, you'll see that chromium has 24 electrons. The atomic number, the smaller number, is 24. So an atom of chromium, these are atoms now, an atom of chromium has 24 electrons. So you need to go and write something. According to Aufbau's principle, you would say that the electrons fill the lowest available the lowest available energy level. So you start writing it, you say 1s2, 2s2, 2p6, okay, 3s2, 3p6, 4s2. Remember that you fill 4s before 3d because 4s has a lower energy value than the 3d sublevel. So count them up now for a second. 2 and 2 is 4 and 6 is 10, 12, 18. Now I have 20. So I would say, according to Aufbau, then you would put the last 4 electrons into the 3d sublevel, okay? But what happens here, and because this is an exception to Aufbau's principle, one of the electrons from the 4s sublevel, okay, goes over to the 3d, and what you end up with is you have 2 half-full sub-levels. Now, from this morning's video, remember, don't mix up sub-levels and main energy levels, you know. So you have 2 half-full sub-levels, which is more stable, and that's why chromium would take that as its electron configuration. Now, the other exception to Aufbau's principle is copper. So you'll have to watch for chromium and copper in the question 4s. Copper's atomic number is 29, which means copper has 29 electrons. So again, same idea, start writing it. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, remember, because it has lower energy than the 3d sublevel. Now, count them up. 2 and 2 is 4 and 6 is 10, 12, 18, 20. So I'd be putting a 9 into my 3d sublevel to satisfy the 29 electrons. But what happens here, this is the exception to Aufbau's principle. One of the electrons from the 4s sublevel switches over to the 3d. So you have 3d10, which is a full sublevel, a full d sublevel, and the 4s is half full, which makes the copper atom more stable. So watch for copper and chromium. They're the exceptions to Aufbau's principle. Okay, thank you.